Hi, it's Mr. Beck, and we are going to talk about significant figures. Now, significant figures help you understand what numbers were measured, what numbers are important, versus what numbers are just kind of extraneous detail that your calculator gives you that you really don't need. So there's kind of numbers that are accurately, presented, and numbers that are just, calculator, residue, we can call it. So if we're taking a look at significant figures, we know a couple of rules. We know that any number that isn't a zero is always going to be a significant value, is always going to be a significant figure, a significant digit. Placeholders are not significant. Now, placeholders might happen as leading zeros on the left or trailing zeros to the right. And the rules are slightly different there. So trailing zeros are only significant if there's a decimal point. And of course, any zero that's sandwiched, that's in the middle of other significant digits, is going to be significant itself. So let's say non-zero numbers are always significant. So here's 5,247. Well, those are all non-zero to me, right? So that is going to be 4 significant figures, or 4 sig figs. Now, 340.25, I've got non-zero digits and I've got non-zero digits. This is what we like to call a sandwiched zero. It comes right in between some other significant digits. So those are all going to be significant digits. So in that case, I've got 1, 2, 3, 4, 5. I've got 5 sig figs. Next, 0.000397. The only purpose of these zeros on the left is to push that 397 off to the right. So with 0.000397, those digits to the left are never, ever, ever going to be significant. Those are what we call leading zeros. So those zeros are not significant values. Now this 3, 9, and 7, those are non-zeros. Those are going to be significant values. So that is going to have 3 sig figs. Next, we have 1,500. Well, these zeros, their only purpose is to push the 1 and the 5 to the left, right? So 1,500, these are trailing zeros. These trailing zeros are not significant in this case. So in this case, I only have 2 sig figs because those are placeholders. Now, this is a little odd, 720 dot. What is that dot doing there? The purpose of that dot is to tell you that I've measured that far. So that 0 actually is significant if there's a dot. If there's a decimal, then the 0 is significant. So that is going to be 3 sig figs. 2.010. Well, I've got a significant digit 2, that non-zero. We know that those are good. This is a sandwiched 0. And so this 0 is a 0 to the right, and we said those are only significant if there's a decimal point. Well, in this case, there isn't a decimal point, so they're not significant. In this case, there is a decimal point, and it's significant. Here, there is a decimal, and that 0 is there because somebody measured that far, because somebody wanted you to know that that 0 is important. So that 0 is also significant because there's a decimal place. So to the right, they're significant if it's a decimal, and so that is 4 sig figs. And finally, 0.0002400. Well, I know these are significant because they're not zeros. These are leading zeros, so they are not significant. These trailing zeros, well, they're significant because there is a decimal place. So those are significant as well. So that's going to give me 5 sig figs. Now, there's a trick with sig figs. There's a shortcut. It might help you, it might not. But I like to think of, the United States. Here, let me draw the United States. How's that for the continental United States? Something like that. Well, this is the Atlantic Ocean. And this is the Pacific Ocean. And so I like to say that every number has an Atlantic and a Pacific side. So for Atlantic, why I say Atlantic? Well, that A means that the decimal is absent. If there is no decimal, the decimal is absent. And I'm going to start from the Atlantic side of the number. If P, Pacific, that means present. If there is a decimal, I will start from the Pacific side of the number and come in this way. So that's my first question is there a decimal? Is there a decimal? And so if it's present, if it's present, I will start at the Pacific side, and if it's absent, I'll start at the Atlantic side. So let's take a look at, say, this 1500. Well, I have 1500. Does it have a decimal? No, it's absent. So I'm going to start at the Atlantic side of that number, and I'm going to start looking in this way until I hit a non-zero number. Up, there it is. Well, that number is significant, and then so are any other digits this way. So I would count, I'd hit the 5, that's significant, and so is the 1, so that would tell me it's 2 sig figs. What if I had a number like 720 dot? Well, 720 dot, the decimal is present. So I'm going to start this way and wait until I see a number that is not a 0. Oh, there's 1. And so that's significant, and so are every other digit in this direction. 1, 2, 3. So that's going to give me 3 sig figs. What if I had 0.0024000? So let's write that one. 0.00240000. Is the decimal absent or present? Well, it's present. It's right there. So I'm going to start from the Pacific side of the number and go in until I hit a non-zero number. Up, there it is. So that one is significant, and so are all the rest in that direction. So that's 1, 2, 3, 4, 5. That is 5 sig figs. So if that's useful, great. If it's not, throw it away, but I just always thought that was kind of fun. Now that you know how to identify how many significant digits, it becomes important in a couple of ways when you're doing calculations. When you're doing calculations, multiplication and division have one set of rules, addition and subtraction have another set of rules. For multiplication and division, your answer can't have any more significant digits than the least number of significant digits in anything you're multiplying or dividing. So for multiplication division, it's the least number of sig figs. So we have a problem here, 210 times 3.67. If I multiply those together, I will get the number 770.7 in my calculator. But how many significant figures are in each one of these numbers? Well, 210, if I take a look at that, I can see that this hundreds place, this 2 is important, this 1 is important, that 0 is not significant because there's no decimal. I could also say decimal is absent, start at the Atlantic, move to the left, I hit the 1 and the 2, I've got 2 sig figs right there. So 2 sig figs. 3.67 has 3 sig figs. All of those are good. So if I have something with 2 sig figs and something with 3 sig figs multiplying together, my answer must be rounded to only 2 sig figs. So the least number of significant digits. So 770.7, if I write that with only 2 sig figs, then that would be 770. Or I could write that as 7.7 times 10 to the 2. In scientific notation, I'm always going to only show sig figs here in scientific notation. My next problem, 0.429 times 37. Well, 0.429, this 4 and the 2 and the 9 are significant digits, so that is 3 sig figs. And 37 has 2 sig figs, and I'm multiplying, and so 3 sig figs times 2 sig figs, my answer can only have 2 sig figs. So 2 sig figs, 15.873 is what my calculator tells me. Well, if I write that with 2 sig figs, that would be, well, it's not 15, it's 15.8 would have to round up to 16. So that is the answer with 2 sig figs. Or you could put 1.6 times 10 to the 1 if you wanted. Now I've got 7 divided by 1.48. So 7 only has 1 sig fig. 1.48 has 3 sig figs, so my answer can only have 1 sig fig. So if I've got 4.7297297.3 is where my calculator stopped, but it looks like the 729 would just repeat. I can only express that with 1 sig fig, so my answer is simply going to be 5. That is 4.729. The 4 gets rounded up to a 5 when I cut it down to just 1 sig fig. So cut it down to the right number of sig figs and round, and again, the least number of sig figs in anything you're multiplying or dividing. Note that your conversions are perfect, so you don't round because of the conversions. You only round given some measurements or some numbers that were put into the problem in the first place. Now, if we're adding and subtracting, it's not the number of sig figs that matter. It's the least significant place that matters. So if this top number, 1480, it was clearly measured, we know that the 1 is significant, we know the 4 is significant, and we know the 8 is significant. What that also means is that the thousands are significant, the hundreds are significant, the tens are significant, but the zero, the ones place, is not significant. What that means is that for this number, 1,480, this is good up to the tens place. I've got another number, 5.2684. This was measured to the ones and to the tenths and to the hundredths and to the thousandths and the 10,000ths. These are all significant. But I can't worry about this 10,000ths place when I'm adding it to something that was only measured up to the closest tens place. So what I do is I line them up and cut them off, is what I like to say. So I do my math, and it's 1,485.2684, but it was only good up until this place. So what I have to do is round to the nearest 10 in this point. So that would be 1,485 rounds up to 1,490. So my answer in addition and subtraction has to go to the least measured place, or the least significant place. So in this case, 1,490. Looking at another addition, what if I had 357,300,000 and I added 97,000 to it? Well, my calculator would tell me 357,397,000. That's fine. But this 3573, none of these digits, these zeros, are significant. It wasn't measured to that amount. In physics, we're dealing with measurements of a reality somewhere. So I'm good for the hundreds of hundreds of millions. I'm good to the tens of millions. I'm good to the millions. I'm good to the hundreds of thousands place, but not to these other places. So again, what I like to say, line them up and cut off. I can only go to the nearest 100,000. So I've got to round this off to 3, 5, 7, comma, well, this 397 turns into a 4, 0, 0, 0, 0, 0. So this is rounded to the least measured place, or the least significant place, not counting number of sig figs. I don't care how many sig figs it is, it's where are those sig figs. This next one is a subtraction, 0.6485. The 6 was measured, the 4 was measured, the 8 was measured, and the 5 was measured. These are all significant digits. Here I've got a 1 and a 5 and a 4 that are significant. And I'm worried about to the right how far. When I add those together, I get 0.63796. Well, this 4 was measured here, but that place was not measured in the top one. So I've got to cut it off there at the nearest 10th, 100,000, 10,000th. So here I've got around 0.63796 to the nearest 10,000th, and that's going to be 0.63, well, 79 becomes 80 when I round it up. 63796 rounds up to 6380, and I've got to leave that 0 there because that's representing this 10,000th place. That's where I cut it off. Shift it over a little bit as I wrote it. Okay, so 0.6380. And now I've got 574 minus 10. Well, that gives me 564, obviously, right? But this 10, the 1 is significant, but the 0 is not. So my ones place is not significant. So again, I've got to line it up and round it and cut it off. So this is going to give me the number 560, where this 0 is not significant, but it's a placeholder. So 560 would be the answer of 574 minus 10. Doesn't sound like it makes sense, but trust me, it makes sense when you're dealing with significant figures. Hopefully that helps. If not, come talk to me and I will help you out a little bit further.